Let's look at another trig graph application problem. We have an extraterrestrial being problem. It says researchers find a creature from an alien planet. Its body temperature is varying sinusoidally. In other words, it's doing this, like a sine graph, cosine graph. It's varying sinusoidally with time. 35 minutes after they start timing, it reaches a high of 120 degrees Fahrenheit. Okay, so 35 minutes after we start timing, so when time is 35 minutes, it reaches its high, and we say it's 120. So here's 120. 20 minutes after that, so here's 35 minutes after we started. 45 minutes is 10 minutes later. At 55 minutes after we started, which is 20 minutes after that, it reaches a low, its next low, of 104. So I'm going to say, here's 104. Okay, so we know it starts, its high is here at 35 minutes after it started timing. Its next low is here. Now, the first thing you have to realize about this problem is it's a little bit different in that, is that one full cycle? No. Going from its first high, or from a high, to the next low is only half of a cycle. So that's basically done half of our cosine. So we need to figure out when it will get back up to a high temperature of 120 again. All right, so if it took 20 minutes to go halfway, it's going to take another 20 minutes to go back up. So 65 and 75 minutes after they started timing is when it gets back up here. So my whole period is actually 40 minutes. That's my period. All right, if 20 minutes takes it from a high to a low, it takes another 20 to go from the low back to the high, and that's 40 minutes. This is not the best cosine I've ever drawn. Sorry, but it's there. Sketch a graph of the sinusoid. Okay, I did that. Now, I'm going to want to find the midline, so let's go ahead and do that. Okay, we can average these two numbers. That's really the easiest way to do it. 120 plus 104 is 224. Take that number, divide by 2. 224 divided by 2 is 112. The other way you could do it is you can figure out that 120 and 104 are 16 degrees apart. So the middle number is going to be 8 degrees from the top and 8 degrees from the bottom. So that's another way you could do it. So here's my graph. Write an equation expressing temperature in terms of minutes since they started timing. So I'm going to do it as a cosine. This is what I need to fill in. My A, my B, my C, and my D. All right, A is amplitude. We already said that it was 8 degrees from the middle to the top, the highest temperature, and from the middle to the bottom temperature, the lowest temperature. So 8 is my amplitude. Cosine. Now B, we have said the value of B is going to be 2 pi divided by your period. In this particular problem, my period is 40 minutes. So 2 pi divided by 40 gives me pi over 8, and that's what goes here. I don't know where I got that. Don't ask me what made me say 8. Pi over 20. 2 over 40 simplifies to 1 over 20, so that's going to be pi over 20. Next, my phase shift. Well, we started here at 35 minutes, so that's my phase shift. So 35 minutes to the right means minus 35. If it had been to the left, I would say plus. And finally, my vertical shift takes it up to the middle line. It's how far it moves it up the middle. So up 112 degrees or plus 112. So here's my equation. I'm going to pop a y equals on there. And that's what goes in the calculator. Let me write my equation. There it is. Now in the calculator, I'm going to put that in very carefully with lots of parentheses. I'm going to put 8 cosine. Put a second set of, let me go ahead and clear this out, make it more clear. 8 cosine. Put a second set of open parentheses and do my pi divided by 20 times, by doing another set of parentheses, theta, which I'm just going to call x, minus 35, and then close the parentheses for everything I'm taking the cosine of. Because it's like this. It's like I'm saying I'm taking the cosine of all of this. Okay? And then plus 112 at the end. Now, looking at this graph, let me go ahead and think about my window values right now. Okay? The time goes from, if we want 0, that's fine, all the way up to 75. So I might want to go maybe 0 to 80 on x. So my x min would be 0 and my x max would be 80. The y values go from 104 to 120. So maybe how about from 80 to 150 so I can see all of it really clearly. So that's what I'm going to put my window values as. So 0 to 180, x min is 0, x max is 80. Y min is 80, y max is 150. For some reason I have something weird on here. Okay, there's the alien's body temperature going up and down and up and down. Now, questions. If they ask me about, let's see, what was its temperature? That's asking me what is x. Okay, so they're not telling, I'm sorry, no, I'm sorry. Excuse me. I got a little messed up by the fact that, I don't know what fact, but I was thinking T for temperature for some reason. But this is time. The temperature here is our height. So temperature here is y. So they're asking me, what is y? When they first started timing, that means when t equals 0. Okay, that's when we first started timing, when t equals 0. So I'm going to plug in t equals 0. That's one way to do it. I did second trace, value x equals 0, enter. And I found out that the temperature was 117.65. Let's go to the 10th and call it 117.7 degrees when they first started timing. Find the first 3 times. So this is x values here are time, y values here are temperature. So the first 3 times means the first 3 x values. So I'm finding x values, which means I can't do this. I can't plug in an x if I'm supposed to be finding an x. First 3 times after they started timing, at which the temperature, y, was 114. So I am looking at when is y equal to 114. So this is when I'm going to plug in another equation, y equals 114. And now, anytime this equation and this equation cross each other, in other words, they have a point of intersection, that's a value where the temperature is 114, and I can figure out when it's happening. So looking back at my graph, now I have a horizontal line that represents temperature is 114, and it says find the first 3 times. So it looks like there's one here, and here, and here. I'm going to zoom in a little bit. I'm going to make my y values a little bit slimmer to make it a little bit more obvious. Here's the temperature going up and down. And the y value, 114. So here's the first time the temperature was 114. Then here's the second time. And here's the third time. So I'm looking for 3 points of intersection. So second trace or calc, excuse me, intersect is 5. First curve just means what 2 things do you want me to find the intersection of? So since I only have 2 things in y equals, I'm just going to press enter, enter. So first curve, enter. Second curve, enter. Okay, guess. This is where it's important to be able to do this. This is why guess matters, because there are a bunch of points of intersection on this graph. They want to know which one do you want to find. So I move it over close to the one I want to find and press enter for guess. And that's the first one. So when time is 3.39 seconds, let's call it 3.4 seconds, the temperature is 114. Then I do the exact same thing again, and the only difference this time is that for guess, I move over to the next point of intersection. 26.6 seconds after they started timing. Do the same exact thing again. And 43.4 seconds. So that's my answer.